Okay, so this is the second problem. In previous class, we have discussed the series of moving load. For that load, the shear force and bending moment is calculated for the given section. But in the question, what we are now taking for the calculations, uh, the simply supported beam, as shown in the figure, which is having 18-meter span, is subjected to a set of four concentrated loads which are moving from left to right. Again, the set of concentrated loads are there, having the center to center distance quite different over here. It is 3 meter, and remaining three loads are having 2 meter consecutive distances. And here these loads are moving from left to right on the span of 18 meter. And when these loads are moving in the span of 18 meter, we need to determine the absolute maximum shear stress which is occurring in the beam, and also we need to calculate the absolute maximum moment because of these loads when these are moving from left to right. That is the question. And here in this case, they have not asked for any of the section. Please, you may have to note it, because in previous problem they have asked for the section at C, the section at C for the 8 meter distance from the left hand. I hope if you remember. But here it is not given any sections and not said that to calculate at that point for the shear and moment. But in general, they said that to determine the absolute maximum shear stress as well as the absolute maximum bending moment for the beam for these concentrated series of loads moving from left to right. So this is the question. So in this question, we need to understand that we are not aiming to calculate at any section. That is the only thing and difference in this problem. So once we start the problem, the question is to be carried out for the further calculations. So 18-meter span with the two supports will be there on the either sides, and the moving from left to right, the direction of the arrow which shows that the movement of the loads. And here in this question, the question already they have given the set of loads, which is the load which is leading and the load which is trailing. On that basis, the load is considered. In other cases, some of the other cases they give that the loads which are moving will be given with a trailing load and a leading load, like that. Based on that, we can able to set these loads. But in this question, they have given the set of loads in the diagram itself. So in the load, it is given 100 kilonewton loads, 80, 60 as well as 80 kilonewton loads, and these four set of concentrated loads having the distance of 3 meter from these two loads, first two loads, and remaining 2 meters consecutive distances. So, but in the same case, if you want to calculate the maximum shear force, what we need to do? So, whenever the maximum shear force is calculated for the any section, the load on the section should be considered near to the point where we are going to calculate the shear. That means whenever a particular beam, I would like to stand with a pen over here, and we can able to understand it easily. Let's take a few seconds over here. Okay, so here if you see, is there any beam having an support over here? If the particular beam is to be calculated for shear force, then the load if you apply on the center, then the shear force value will be almost equal to 0 over here. But if you apply load over the near the support, then shear force value will be maximum. Do you people agree with this content? Are you people agree with this? When the shear force or loads are acting near the supports, then the shear force will be maximum over here. Yes. Okay. That means here in this case the same thing is adopted for the calculation for absolute maximum negative shear. Negative shear is written is because we have considered the set of loads over the supports, over the right supports, sorry, left supports, and the load position are already shown in the diagram over here. So in this, again, it is nothing but we need to have the coefficient values. So how do you get the coefficient values? Just see, I hope it is clearly visible. For set of loads, 50 that is 80 kilonewton load, which is acting at the point that support, acting at the point of support, and the remaining loads are acting with the respective distances. With respect to here, in 18 meter, the first set of load is acting from the right support. From the right support, how much it is, and from the left support, how much it is. We can able to calculate by referring to the distances over here. So here it is 3 meter, and here it is 2 meter, and here it is 2 meter, right? So in the total 18 meter, how much it is? 3 plus 2, 5 plus 7, that is total 7 meters, and remaining will be 11 by 18. That means up to from here, from this supports, it is measured 11 meter to this one. How we have considered 11 meter? That is deducted this 2 and this 2 and again this 3 meters, right? And from here to here it is 11. Again, if you consider for this point, then how it will be? 11 plus 3. 11 plus 3 will be 14 by 18. 18 is the total span. Again, for this concentrated load, the coefficient value will be 14 plus 2 will 16. 16 divided by 18, right? And this is how the coefficient values are considered. And for this it will be 18 by 18 because at the point, at the support, we don't have any other span and any other loads from this section. On the support it will be again as usual, that is unit. And now and here if you see, the coefficient values need to be multiplied with the intensity of load to calculate the maximum shear. However, the whatever the procedure is carrying out here, it is for support reactions. The support reaction is nothing but the shear which is acting at the point itself. That will be the maximum shear that we can expect in the beam when the loads are acting near the supports. So let us consider one by one over here. So this is the first load which is considering 80 with the intensity 1 over here, 80 into 1, right? And next this 80, sorry, this 60 into 16 by 18, 60 into 16 by 18, it is considered over here again. And next we have this 80, this 80 into 14 by 18, this 80 into 14 by 18. Again we have 100 into 11 by 18. That is the things. That means the intensity of load multiplied with the coefficient values. The coefficient values you can always calculate in this manner, like this, right? So now once you solve for this, it will be of 176.66 kilonewtons. At this support, when the loads are placed on the near support of A. So at the same time, if you place those supports towards the support B or towards the right, then we can say that the positive shear force. Then again the loads are measured from the distance of other end over here. So other end means here, if you see, it is this end for the loads which is setting for the right side, that is right side, and previously what we have seen, that is for left side, that is support from left side. So again it is, if you measure the first distance will be of 18 and second will be of 13, and here it is 2 meters, right? In the total span of 18, so if you see in the 11 meters are deducted, then it will be of 11, that is 18 minus 11. So 18 minus 7 will be 11 over here. The 7 is because 3 plus 2 plus 2, So up to from here to here it is 7 meter, and from here total distance is 18. In this 18, if you deduct this 7, from here it will be 11 meters. And from here, from this support to here, it will be 11 plus 2 will be 13. Again 13 plus 2 will be 15, and 15 plus 3 will be 18 over here. 18 by 18 will be 1. 18 by 18 will be 1 over here. So again, with respect to these, if you calculate the values of shear force, then this 80, this 80 into 11 by 18. This 80 into 11 by 18, that is the value over here, and then 60 into 13 by 18. Just we are multiplying the coefficient values for the intensity of load. Again 80 into 15 by 18, then 100 into 1, which is equal to 100. Then the total shear force what we can expect from the load when it is placed right side near the support is 258.889 kilonewtons. That means the maximum shear force on the support is, so what they have asked to calculate the maximum absolute maximum shear stress is nothing but 258.889 kilonewtons. So this is how we need to calculate the maximum shear force for the support. But here we are not saying any negative shear force or positive shear force. Just we are saying that the maximum shear force, whether it is negative or positive. We are not representing with sign or any notes. Just the maximum shear force is calculated. Is this clear, dear students?
Yes, sir.
Okay, remaining. How many of you people listening over here? Is this clear?
Yes, sir.
Okay. Now, another thing is absolute maximum moment. Next one is need to calculate the maximum moment. So here it is just quite lengthier to calculate here, because the series of loads are having a different intensity of intensity. So in this we need to have an CG of the loads. Again, the same thing what we had considered in the previous problem, and here it is also need to carry the same thing. So for finding absolute maximum moment, before that we should know, so whenever there is a beam, if the beam is loaded, any kind of loads, whether it is uniformly distributed load or concentrated loads or uniformly varying loads, any kind of loads, if the loads are placed at the center of the span, the bending moment will be of in this manner, right? And at the same time, if the particular load is placed at this point, then bending moment will be like this. And again, the load is placed at this point, right? And the bending moment will be like this. That means the load, where the position of the load where you are placing, that will be matters a lot. So on this content, I would like to ask you, any one of you, please let me know, in which place, if you place the load, you to get the maximum bending moment. In which place do you say or prefer to place the load of set of loads to get maximum bending moment?
So center.
Center,
At the
right?
center.
Okay. So on this concept, if you see the concept, here we have set of loads, correct? In this set of loads, we need to have, we don't know where exactly the center of this set of loads. But if have only one concentrated load, then it would be easier to us to have a centrally placed and then to get maximum moment. But in this case, we don't have any that is center point for these loads. In that case, we are now calculating for the CG of the loads. So how do you calculate the CG? That means here just we can take any one of the point as a hinge, then we can all loads are taking into multiplying with the distances. So taking moment about leading load, just do observe over here what the calculation is taken place for the CG. So when the taking moment about the leading load 100 kilonewton. So this for 100 kilonewton the leading load is considered, and this 80 into 2 plus 2 plus 3 is there. This 80 into 3 it is first one, and next 60 into 5 and 80 into 7. The same thing is written over here. Just 80 into 3, and that is 80 into 3 written over here, and then next 60 into 5, 60 into 5 it is written over here, and then 80 into 7, that's 80 into 7 it is written, and divided by total sum of loads 100, 80, 60 and 80. So all set of loads if you take, then 3.437 meters it is getting. So 3.437 meters if you get, then this distance, whatever we have got the distance, which is nearer to the load of 80 kilonewton, because we have taken the point over here. If you measure 3.47, it will be near to 80 kilonewton, right? That means exactly it is not lying with the 3, it is having some 0.437 meters of eccentricity, right? Are you getting what exactly I am telling here? See, this is the load case, and here we have 100 kilonewton load, and here we have 80 kilonewton load, and here we have another 60 kilonewton load, and again this is another load. So for this, what we have got is 3.437. That will be again at this point itself. That might be lying with this, but we have here it is 3 meter. But here we have it is 3 meter, right? So, but remaining thing is 0.437, which is eccentrically acting for this 80 kilonewton load, right? So that means the distance of this one is 0.437. Are you getting? This is how we have taken the center of gravity of these all loads taking moment for the 100 kilonewton leading load, and then we have got 3.437 meter of distance from this end. So once you measure the distance of 3.437 from this end, it will be acting nearly over here, nearly to the support, that nearly to the load of 80 kilonewton. So here 80 kilonewton load if you take, it is 3 meter, and remaining we have 0.437 meters. Am I right? So here, if the 0.437 is left, and that would be considered on half, because to have on either side, to have the CG on either side. It is the point where, because on this point we need to have the uh, position need to consider. The same thing I have written, what I have discussed, the same thing is written over here. Hence, the maximum amount moment likely to occur under 80 kilonewton load, which is leading, because we have two loads over here. We have two 80 kilonewton loads, and these two 80 kilonewton loads, this 80 is the leading. That is why it is denoted with the notation 80 kilonewton leading load. The distance between these loads and resultant D, the resultant D is nothing but this one. Okay. So now D minus 3 meter. 3 meter is because this is the 3 meter, the distance between 100 to 80, because from here we are measuring. So 3.437 minus 3 will be 0.437. For this, now we need to have SCG, because the load need to be placed center to the span, right? So it is the 18 meter span. We will be having 9 meter on either side. So this 9-meter span need to coincide with the set of loads at what distance? That distance is measured over here. So L is the 18 meter, 18 by 2, and we have eccentric value of 0.437, that is multiplying and dividing with the 2 to have the CG. So here, if this point is getting, and this point need to placed from the left end of this 9.218, and just I will show you the diagram. The same diagram is already drawn over here, right? This 9.218 meter we are obtaining, which is placed from the right end, because we have already measured from the left end of 3, and when the section is passed for the CG, it is remained with zero point 4 something, and for this zero point 4 meter, and when we take the CG, then which we need to coincide to the center of the load, that is the CG, to the span of the 18 meter. So once we get the 9.218 meter, at that position we need to place the 80 kilonewton load. So here 9.218 is the distance what we have got. From for that point we need to place this load, because the center is here, but somewhere it is lying more than the center point. Then to get the center of all loads for the span of 18 meter. Once we place here, then remaining distance in 18 meter will be 18 minus 9.218 will give 8.782 meters. So here this 8.782 meters are having the consideration to get the coefficient value for these loads which are acting with the certain distances on each other. So here the same thing, the loads have been calculated by referring to the distances on either sides of the section. So here let's see y1. So y1 is the point. On this point we are going to calculate the CG. So how do you calculate the CG over here? So in the total span of 9.218 meter, we have 2 plus 2 meter need to be deducted, because we have to consider on this point. So 9.218 minus 4 will give 5.218, right? And now for this, if you want to see for this, that is y2, y2 will be in 9.218, we need to deduct 2, and will be 7.218, because it is 2 meter distance here up to here, and from here to here it is 4 meter. That is why it is deducted for 4 in the 9.218, and here it is deducted for 2 in the 9.218 to get this coefficient for y2, right? And then for yc is considered, C is considered as a section, because if you place the load on this section, then only you will be going to get the maximum absolute bending moment. That is the case we are taking the yc. And for bending moment, this formula we have already derived. We know this basic content, that z is nothing but this one, the distance of this one, and remaining distance will be this one. And here z is nothing but 9.218, and L is 18 meter. And if you substitute, you will be getting 4.497. That is what nothing but yc. And again, to get this y, that is y3 load, set coefficient of y3. So how do you get the total span of 8.782 meter is there on the right side, having the coefficient value of the distance, sorry, that is the distance from here. If you deduct, that is 3 meter in the span of 8.782, the n will be end up with here, and that will be remained with 5.782. That means 8.782 minus 3. 3 is because this distance, that to up to here. If you deduct this, then you will be able to get this section load. 3 is considered when it is acted with a 3 meter distance on either. So 3, if you deduct, we will be getting 5.782 divided by 8.782. right? And this will be getting the coefficient value. After getting the coefficient value, we need to have the multiplication for the load into intensity, and that is intensity of load into coefficient values along with the YC. We need to remember this. In this moving load, we need to multiply this YC over all the sections where we are going to calculate. See here, uh, 80 into 5.218 by 9.21, that is the coefficient value we have multiplied, and again all together we have multiplied this YC value, that is how it is written, 60 into 7.218 by 9.218, which is having uh, coefficient for the 60 kilonewton, plus 80 need to be multiplied with YC, and YC will be multiplied all together, and 100 into 5.782 by 8.782, which is coefficient. For this, for all the sections, we have multiplied 4.497 as a total load. So once we multiply, we will be getting the total absolute bending moment on the section is 1070.77 kilonewton meters. And this is how we need to have the calculation for absolute bending moment and maximum shear force on the given span. And dear students, is that clear? Right, and whatever we have discussed, is that clear?
Yes, sir.
Okay. And again, the notes already shared in your WhatsApp group. Please go through that. This problem is there in that note, and just try to solve on your own. Just seeing once, and later you'll be able to solve. Then it is no problem. If you have got doubts, please let me know, and we can solve it. And one more thing, Chandrika, are you listening? Some have doubts have been asked by Chandrika, and at the same time, the solution is given. I don't know whether she solved it or not. Chandrika Ergatti. Yes, Chandrika, are you listening? And just you have asked me a doubt in the problem of the method of sections. I think method of section or method of joint in the truss to get the forces. Isn't it you, right? Okay. Anyhow, your mic is open. Then you can speak it. Okay. I don't know why people sit quiet. If even if the discussion is taking place, let it be. So this is the total discussion we have discussed in the problem. So I hope everything is clear for you. And again, I will after this class, I would like to give you assignment, whether or else you can take the assignment now itself. Whatever the question paper is, question is solved right now. On the same question, the span is different and the load is different. The span is different and the load is different. I will just try to give an assignment, and please make a note on this, and then you can able to calculate the calculation values over here, and then again I will give the values for this. Okay. Just I will draw over here the same thing, the same question, and that is the train of concentrated loads which are moving from left to right, and the simply supported girder span of 16 meter. Determine absolute maximum shear and bending moment developed in the beam. So beam having like this, and the supports are like this, and the span is 16 meter. Please take this diagram on your books and try to solve this by referring to the problems what we have discussed now. and the loads are given like this, which is having 4 concentrated loads, like this, and having the distances of 2 meter, 2 meter and 3 meter, and the intensity of load is 40 kilonewtons. All loads are in kilonewtons itself, please do note it. And here it is 80, and here it is 60, and here it is 20. Right. So let us say this as a support A, and let us say this as a support B. Now, the same question what we had discussed today is but the span is different, and the load and the center to center distance between the loads are different. And I will write the answers for this. The maximum shear. The question I will just repeat. The train of concentrated loads which moves from left to right on the simply supported girder of 16 meter, determine the absolute maximum shear force and bending moment developed in the beam. Again, they have not asked any section over here. And keep it in mind, these types of question will be there in your external exams in all the question papers. Whatever we had referred in previous question papers, these types of questions will be there absolutely, and they are going to carry a maximum weightage of more than 50% of marks for your particular modules, right? So maximum shear force when you calculate, just I will write SF. It is the answer. Just you can verify over yourself, and the some values of that is for 2.25 like this, they may get vary. That is absolute shear force of 166.25. That is the answer for the maximum shear force once we calculate. And the bending moment. Bending moment is 651.52. 651.52, which is having kilonewton meter. Which is having kilonewton meter on the unit, and it is kilonewton. Right? And do you people solve this?
Yes, sir.
Okay. And the same question what we had discussed today, but the span and the load intensities are different. I think the whatever numbers I have written, it is clearly visible, and you can notify these things. Do you get any confusions or any values to get over here? Shear force value is 166.25 and bending moment value is 651.5. So just solve this question, and let us check on yourself how much you are getting over it, how much you are getting actually actual values, and try to solve first what we have discussed today, and later we can solve this one. Okay. And in coming class,
Is this assignment, sir?
as an assignment you can consider. See, one thing I want to tell you people, only it is not like that you need to solve only assignment questions. Whenever you get the questions regarding your syllabus, it is your question only to solve it. It should not be in the way of assignment only. Okay. But you can solve it as an assignment. You can add this question in the assignment number 1, and also share with your friends. You can add this question as an assignment number 1, and then we'll take it.
Okay, sir.
Okay. Only thing is, whatever you are doing is for you people only, for yourself. It is nothing will help for others. And try to solve on your own. Make your time and get it. The question solved. But tomorrow class, I would like to discuss these things first, and later we'll start the discussing about the upcoming different kinds of problems on these moving loads. With this note, I would like to conclude this class. See you tomorrow in the next class.
Sir, please put all those problems notes.
I have already shared on the notes. I have already shared the
Okay,
notes
sir.
in your WhatsApp.
Okay. Yesterday you said.
Yesterday I have shared, no, in that note only it is there the question. But today's assignment question, it is not there in the solution. So try it on your own.
Okay, sir.
Okay. Everyone, I request